NEC Section 547.20b states that for exterior applications, motors shall be rated for the specific environmental conditions. NEC Section 547.20e states that enclosures for outdoor applications shall be weatherproof. NEC Section 503.3b states that roof-mounted pressurization equipment shall be provided with an enclosure suitable for the location. Based on the NEC requirements, the motor inside a roof-mounted pressurization fan enclosure must be rated NEMA 3R or better to withstand the outdoor environment, which may include rain, snow, and high winds. The enclosure itself must be weatherproof to protect the motor and other components from the elements. It is important to select a fan enclosure that meets the specific environmental conditions at the installation site. Regular maintenance and inspection of the fan enclosure and motor are essential to ensure proper operation and longevity. Refer to the manufacturer's instructions and specifications for specific requirements related to the fan enclosure and motor rating. When selecting a motor, several factors beyond the minimum NEMA 3R rating should be considered to ensure reliable operation and longevity in a roof-mounted pressurization fan application. Firstly, consider the ambient temperature range in the location. The motor should be rated to operate within the expected high and low temperatures. Secondly, evaluate the humidity levels. High humidity can lead to corrosion and premature motor failure. A motor with enhanced moisture protection may be necessary. Thirdly, assess the potential for exposure to specific contaminants such as dust, chemicals, or salt spray. Choose a motor with appropriate ingress protection to prevent these contaminants from entering and damaging the motor. Fourthly, consider the altitude. Motors operated at high altitudes may require special considerations due to reduced air density. Fifthly, select a motor with appropriate overload protection. Overload protection devices such as thermal overload relays or circuit breakers should be sized correctly to protect the motor from damage due to excessive current draw. Sixthly, ensure the motor's insulation class is suitable for the operating environment. Higher insulation classes provide better protection against heat and moisture. Seventhly, consider the motor's efficiency rating. Higher efficiency motors can reduce energy consumption and operating costs. Eighthly, choose a motor with a service factor greater than 1.0. A service factor indicates the motor's ability to handle occasional overloads without damage. Ninthly, select a motor with bearings that are suitable for the application. Sealed bearings or bearings with provisions for lubrication may be necessary to ensure long life. Tenthly, consider the motor's vibration levels. High vibration can lead to premature bearing failure and other problems. Choose a motor with low vibration characteristics. In addition to the motor rating, the enclosure rating is also critical for protecting the motor and other components from the elements. A weatherproof enclosure is designed to prevent water, snow, and ice from entering and damaging the internal components. Firstly, consider the ingress protection rating, often expressed as an IP code. The IP code indicates the enclosure's level of protection against solid objects and liquids. Secondly, choose an enclosure made from a corrosion-resistant material such as stainless steel, aluminum, or fiberglass reinforced plastic. Thirdly, ensure the enclosure has a tight sealing lid or door to prevent water from entering. Fourthly, consider the enclosure's ability to withstand extreme temperatures. Choose an enclosure made from a material that will not become brittle or deform in extreme temperatures. Fifthly, ensure the enclosure has adequate ventilation to prevent condensation from forming inside. Sixthly, consider the enclosure's size. The enclosure should be large enough to accommodate the motor and other components, with enough space for wiring and maintenance. Seventhly, choose an enclosure with a sloping roof to prevent water from pooling on top. Eighthly, ensure the enclosure has a secure locking mechanism to prevent unauthorized access. Ninthly, consider the enclosure's mounting options. The enclosure should be mounted securely to a stable surface. Tenthly, choose an enclosure that is easy to maintain and inspect. The enclosure should have a removable lid or door for easy access to the internal components. When installing a roof-mounted pressurization fan, it is important to follow all applicable electrical codes and safety regulations. Firstly, ensure the installation is performed by a qualified electrician. Secondly, use the correct wiring methods and materials. Thirdly, ground the motor and enclosure properly. Fourthly, install overcurrent protection devices such as circuit breakers or fuses to protect the motor and wiring from damage due to overloads or short circuits. Fifthly, provide a disconnect switch within sight of the motor to allow for safe maintenance and repair. Sixthly, label all electrical components clearly. Seventhly, inspect the installation regularly to ensure it is in good condition. Eighthly, keep the area around the fan clear of obstructions. Ninthly, follow the manufacturer's instructions for installation and maintenance. Tenthly, comply with all applicable local codes and regulations. The National Electrical Code, or NEC, provides specific requirements for electrical installations in various locations, including those exposed to the weather. Several articles within the NEC are particularly relevant to roof-mounted pressurization fans. NEC Section 430 covers motors, motor circuits, and controllers. This article provides requirements for motor protection, overload protection, and disconnecting means. NEC Section 440 covers air conditioning and refrigeration equipment. This article provides requirements for the installation and wiring of air conditioning and refrigeration equipment, including roof-mounted units. NEC Section 547 covers agricultural buildings. While not directly applicable to all roof-mounted pressurization fans, this article provides valuable guidance on the selection and installation of electrical equipment in corrosive environments. NEC Section 300 covers general wiring methods. This article provides requirements for wiring in various locations, including those exposed to the weather. NEC Section 310 covers conductors for general wiring. This article provides requirements for the selection and sizing of conductors. NEC Section 250 covers grounding and bonding. This article provides requirements for grounding and bonding electrical systems to ensure safety. NEC Section 110 covers requirements for electrical installations. This article provides general requirements for electrical installations, including those related to safety and workmanship. It is essential to consult the latest edition of the NEC and any applicable local codes before installing a roof-mounted pressurization fan. The NEC is updated every 3 years, so it is important to ensure you are using the most current version. Local codes may also have additional requirements that must be followed. Understanding NEMA ratings is crucial when selecting electrical equipment for outdoor use. NEMA, or the National Electrical Manufacturers Association, establishes standards for the design, construction, and performance of electrical enclosures. NEMA ratings indicate the level of protection an enclosure provides against various environmental conditions. A NEMA 3R enclosure is designed to provide protection against rain, sleet, snow, and ice formation. It is suitable for outdoor applications where exposure to these elements is expected. However, a NEMA 3R enclosure is not necessarily watertight. It may allow some water to enter under certain conditions. A NEMA 4 enclosure provides a higher level of protection than a NEMA 3R enclosure. It is designed to be watertight and to prevent water from entering even when subjected to hose down. A NEMA 4X enclosure provides the same level of protection as a NEMA 4 enclosure, but it is also corrosion resistant. It is suitable for use in environments where exposure to corrosive substances is expected. When selecting a NEMA rating, consider the specific environmental conditions at the installation site. If the equipment will be exposed to rain, sleet, snow, and ice, a NEMA 3R enclosure may be sufficient. However, if the equipment will be subjected to hose down or will be located in a corrosive environment, a NEMA 4 or NEMA 4X enclosure may be necessary. It is also important to consider the enclosure's construction. Enclosures made from stainless steel, aluminum, or fiberglass reinforced plastic are generally more durable and corrosion resistant than those made from carbon steel. The NEC requires that electrical equipment be suitable for the environment in which it is installed. This means that the equipment must be able to withstand the expected environmental conditions without causing a safety hazard. In wet locations, the NEC requires that electrical equipment be weatherproof. Weatherproof equipment is designed to prevent water from entering and damaging the internal components. The NEC also requires that electrical equipment be protected from physical damage. This can be accomplished by installing the equipment in a protected location or by using a suitable enclosure. When selecting electrical equipment for outdoor use, it is important to consider all of these requirements to ensure a safe and reliable installation. Remember that regular maintenance and inspection are essential for ensuring the longevity and proper operation of roof-mounted pressurization fans. Firstly, inspect the fan and enclosure regularly for any signs of damage or wear. Secondly, clean the fan blades and motor regularly to remove dirt and debris. Thirdly, lubricate the motor bearings as needed. Fourthly, check the wiring connections to ensure they are tight and corrosion-free. Fifthly, inspect the enclosure seals to ensure they are intact and preventing water from entering. Sixthly, test the fan's operation to ensure it is running smoothly and efficiently. Seventhly, replace any worn or damaged parts promptly. Eighthly, keep the area around the fan clear of obstructions. Ninthly, follow the manufacturer's instructions for maintenance and inspection. Tenthly, consult a qualified electrician if you have any questions or concerns. Proper maintenance and inspection can help prevent costly repairs and extend the life of the fan. Ignoring maintenance can lead to premature failure and safety hazards. By following a regular maintenance schedule, you can ensure that your roof-mounted pressurization fan operates safely and efficiently for many years to come. Also, consider the fan's performance specifications, including airflow capacity measured in cubic feet per minute or CFM and static pressure measured in inches of water gauge. Select a fan with sufficient airflow capacity and static pressure to meet the ventilation requirements of the building. Oversizing the fan can lead to energy waste, while undersizing the fan can result in inadequate ventilation. Consider the fan's noise level. Roof-mounted fans can generate noise that may be objectionable to building occupants or neighbors. Select a fan with a low noise level to minimize noise pollution. Also, consider the fan's energy efficiency. High-efficiency fans can reduce energy consumption and operating costs. Look for fans that are certified by the Air Movement and Control Association or AMCA. AMCA certification ensures that the fan's performance has been independently tested and verified. Also, consider the fan's control options. Fans can be controlled manually or automatically. Automatic controls can adjust the fan's speed based on temperature, humidity, or occupancy levels. This can help to save energy and improve ventilation performance. Also, consider the fan's warranty. A longer warranty provides greater assurance of the fan's reliability. Also, consider the fan's availability and lead time. Some fans may be readily available, while others may have a longer lead time. This is an important consideration if you need to install the fan quickly. Also, consider the fan's cost. The cost of a roof-mounted fan can vary depending on its size, performance, and features. Compare the costs of different fans before making a decision. Also, consider the fan's manufacturer's reputation. Choose a fan from a reputable manufacturer with a proven track record of quality and reliability. Also, consider the fan's service and support. Ensure that the manufacturer provides adequate service and support in case of problems. Also, consider the fan's compliance with applicable codes and standards. Ensure that the fan meets all applicable codes and standards, including those related to electrical safety, fire safety, and ventilation. Remember that selecting the right roof-mounted pressurization fan is a critical decision that can impact the building's ventilation performance, energy efficiency, and indoor air quality. Take the time to carefully consider all of the factors discussed above before making a decision.